Can you see the screen? Can everyone see the screen?
Yes, sir.
So in the last class, what we have done is about the IUPAC nomenclature, and we have also learned about the S block, B block, D block, and the F block L. Now today we are going to see about screening effect and of the shielding. Now these are a bit of conceptual parts. Screening effect or the shielding effect. Screening effect of the shielding. So it is as if the inner electrons over here will behave like a screen. It's what I mean by that. Screening. First, let me draw and write down the explanation, then I will explain. An important question, also theory question for your examination purpose. Let's try to understand this. What happens in this spinning effect? So what is the work of the nucleus? What does the nucleus do? The work of the nucleus is to pull the electron towards itself. Right? So the function of the nucleus is to pull the outermost electron, that is this red electron, towards itself. So this is what the electron does. And this is what the nucleus does. Now, but between the nucleus and this outermost electron, there are also other orbits. And those other orbits also contain electrons. Other electrons are also there. So you think that the nucleus is trying to pull the electron towards itself. But these electrons present in the inner orbit, what they are doing is they are forcing the electron away. So they are repelling the electron out. So it is basically two types of forces actually acting on this electron. One is the force of attraction by the nucleus. So one force is that the nucleus is attracting the outermost electron. And another one is going to be the force of repulsion. But who is repelling? That is, these inner electrons are trying to repel the outermost electron because everyone wants to remain away from each other. No one wants to share their place with one another. So that is why the moment that the outermost electron tries to come close to the nucleus, what will happen is that the inner electrons will push the outermost electron, repel away the outermost electron. So that means this outermost electron has two types of force. One is an attractive force by the nucleus, and another one is the repulsive force by the inner electrons. Is this much clear to everyone? How the
Yes, sir.
electron
Yes, sir.
experiences two types of forces. One is attractive force, and another one being the repulsive. Okay. Now, so now if this is the repulsive force, now you consider one situation. Suppose a train is moving theoretically at a speed of 100 km per hour. So if a train is moving at a speed of 100 km per hour on pen and paper, do you think it move with that speed in real life? No, it won't be moving with 100 km per hour in real life situation because in real life situation there is the friction of the railway tracks and also there is a friction by the air. That means in real life situation, speed of the train is much lesser. For example, 80 km per hour. So even though on pen and paper it appears the train move at 100 km per hour, basically in real life situation, due to this friction, we are getting to see that the train is actually moving at 80 km per hour. So here also, due to this repulsive force by this inner electron, the outermost electron actually cannot experience the total amount of attractive force. That is, the outermost electron cannot feel the total pull by the nucleus. That is, it cannot feel the total nuclear charge. Rather, it can only experience a part of the total. And that part of the nuclear charge is only called the effective nuclear charge. What did I say in this slide? That is, it is due to this repulsive force of by the inner electrons, we are getting to see that the outermost electron cannot experience the total pull of the nucleus. That is, it cannot experience the total nuclear charge. Rather, only feel a portion of it. And this is only called the and this is called the effective nuclear charge. So we can as if say that the electrons present inside, that is this inner electron, it is as if behaving like a barrier or a shield. So it can be said that the inner electrons is behaving like a barrier or a screen or a shield. Between whom is it acting? Between the nucleus and the outermost. So this green color zone that I have drawn, that is the inner electron, which is acting like a barrier or a screen or a shield between the nucleus and the outermost. It's as if it is stopping the nucleus from pulling this outermost electron. Hence, this phenomenon is called the screening or the shielding effect. Is it completely clear to everyone? Is there anyone for whom it is not clear? Can you let me know? Clear to everyone?
Yes, sir.
Yes, sir.
How many are doing the class at this moment?
Three.
Three. Who is the other one?
Papia, sir.
Abia, is it clear?
Yes, sir, it is clear.
Please respond when I ask. Okay? Otherwise, I
Yes,
am
sir, clear, sir.
now I got to hear. Respond. Otherwise, I cannot understand whether you are there or not. So that was your screening effect. Now see, we have already learned in the previous chapter that is there are different types of orbital S, P, and the D, and F orbital. S, P, D, F subshells and orbitals are there. Now, obviously, all orbitals do not have the same power of screening the electron. The different orbitals have different power of screening effect. So now let us know the order of this screening. So the screening effect, the screening effect the screening effect of s orbital is greater than p, greater than d, s greater than p, greater than d, greater than f. So that means s orbital can screen the electron, screen the nucleus of the electron most effectively. S can screen the nucleus of the electron most effectively. Whereas AF orbitals cannot screen the electron of the nucleus effectively. So it has a very poor screening effect. AF orbitals has a very poor screening effect. Now, why is it so? What is the reason behind it? So, for that, understanding the reason, let's take it, consider it like as a game-like situation. Suppose this is a 4. Suppose this is a 4, and in your video game, you have to actually make your own army and protect this 4. So now tell me, which is a better line of protection? If your army in this way, will it be better? Or arrange your army in this way, will it be? That is, arrange them in this way. Which line of defense will give you a better protection of your home? The first one or the second one? Which is a better protection for your for this building?
First one.
The first one is a better protection. Why? Because over here you are getting an all-round protection around the front. But over here, it is just one-sided protection. Enemies can attack from any of these sides, and then you will be left without any line of defenses. But in the first case, you are getting it can give you 360-degree protection from all the enemies. So for spreading effect also, the S orbital does the most effective spreading. Why? Because S orbital we have already done in your atomic structure. That is the shape of S orbital is spherical. So S orbital is spherical in shape. So that means we can spin the outermost electron from every direction possible. But as we move from P to D and finally to F, we are getting to see that the shape of the orbitals is becoming more and more diffused. That means the shape of the orbital is becoming opened up. That means now it cannot spin the electron so much effectively as the structure has become more and more diffuse. So this is the reason of why S orbital has the best spinning and the S orbital has the poorest spinning effect. Okay. Now what about the another effect is penetrating effect. Penetrating effect. And this also has the same order. That is the penetrating effect. The penetrating effect of S orbital greater than P orbital greater than D, finally greater than F. So why is it so? Now what is this penetrating effect before that? So penetrating effect is the ability of the orbital penetrate to the screen of the inner electron. So the penetrating effect of an orbital is the power of an orbital to penetrate through the screen caused by the inner electron. And for penetrating effect also we are seeing that S orbital has the best penetrating. So these two conclusions are very important. That is poor spinning effect of F electrons and high penetrating effect of S orbital. Because in many of the give reason questions of this chapter, we will explain our answer with these two keywords only. That is the poor spinning effect of F orbital and the very high penetrating effect of S orbital. So our answer will be based on this point. So this order of screening and the penetrating effect is important for you to remember. So, then let's move on to the next topic, that is the periodic property. So this was an overall introduction, not introduction we had done it in the previous class only. So now we are going to see basically your periodic properties. Now what do we mean by periodic properties? Anyone tell me what do we mean by periodic properties? What is the meaning of periodic property? Do you know this? You have done it class 10, I guess. What is the meaning of periodic properties? The properties in the periodic table which repeat itself after a certain interval, that is called a periodic property. Properties in the periodic table which repeat itself after a certain interval, that is called a periodic property. Okay. So under periodic property, we are going to study about four things mainly. That is atomic size, ionization energy, electron affinity, and electronegativity. So let's write periodic properties. That will be properties in the periodic table which repeat after a certain interval properties in the periodic table which repeat after a certain interval is called periodic properties. So we have four periodic properties. One is atomic size, and we have many periodic properties. We are going to mainly discuss about this. One is the atomic size. Ionization energy. Electron affinity. Electron negativity. So these are the four things that we discuss. Starting with atomic size. Do you know what happens to atomic size if we move across the period? Do you know how atomic size will vary if we move across the period? Yes or no?
Yes, sir.
So what will happen to atomic size on moving across the period?
Sir, it will be increase.
It will increase, okay. And what will happen if I move down the group then?
It will decrease.
Then it happen basically opposite, huh? Just opposite. Okay, why? Why will it increase or why will it decrease? Do you know the reason? We move from the top of the periodic table to the bottom. That is, if I move from top to bottom, then that is called technically as moving down the group. So do not try on moving from top to bottom. It's not a right thing. If you are moving from top to bottom, then the technical word is on moving down the group. So now let's see what happens when you move down the group. On going down the group, So what will happen? You see, if we just use our class 10 concept only. So group 1 মানে lithium, sodium, potassium, like this way. So if I take some shapes from here. So this is one orbit of lithium, and this is the nucleus. This is your lithium, Li in the nucleus, and one orbit, not only one orbit, rather two orbits. Lithium has two orbits. How to move to cell? Sorry. This is your lithium. Lithium has two orbits. Okay. For sodium, if I take sodium, will have three orbits. Structure of sodium. Right. So can you see? As the number of orbit is increasing, what is happening? The atomic size is increasing because now there are greater number of orbits circling the nucleus. So naturally, the atomic size will also increase. For potassium, the atomic size even increases more. So you see, for lithium, you compare the size and compare the size for potassium and sodium. So what happens for going down that is on going down the group, what happens? The number of on going down the group, the number of shells increase due to an increase in principal quantum number. Hence, atomic size atomic size increases increases down the group. Okay, so this is the thing, that is on going down the group, we are getting to see that the number of shell is increasing because the principal quantum number is, and thus it is due to this reason we are seeing that the atomic size is also increasing down the group. So down the group, atomic size increases. It does not decrease. Okay, so down the group, our atomic size will be increasing. Okay, is it clear why atomic size now increases down the group? I hope you will not make any further mistakes after this.
Yes,
But
sir.
remember the diagram. Let's see from the diagram only you can clearly see that as the number of shell is increasing, so does the atomic number will increase. That's the answer. On going down the group, the number of shell increases because the principal quantum number. Hence, you are getting to see that atomic size increases down the group. Now, what will happen if you move across the group? Now, let's see what happens if you move across the group. That is, if I move left to right of a period, then that is technically called as moving across the period. We will not be writing it as a moving left to right of a period. Rather, we will write it as or moving across the period. So, across the period, what will happen? Atomic size will decrease. Across the period, we are getting to see that atomic size will basically decrease and not increase. Why is it so? Let's see. So, on moving across the period, any idea? Think of your answer. See, this chapter is in that way easy because and hard also at the same time because here you cannot remember or memorize your answers. Here you have to think of the result. Mainly in your questions, you will give result type of question from this topic. So it will be mostly about thinking down the middle. So tell me, why should atomic size decrease across a period? Why should the atomic size decrease across a period? What do you think should be the answer? Why should atomic size decrease across a period? If is it right? At least it will be wrong. Mathematics, nothing else.
So the nuclear attraction increases
Yes. Why? Why does it increase? Why does the nuclear attraction increases?
because the outermost electron is more across
Outermost electron increases. Yes, correct. So that's the reason. So on moving across the period, what happens is that the the number of shell remains constant. Number of shell does not change; it remains constant. The number of shells remains constant. However, the the number of shell remains constant. However, the number of valence electron, that is the number of electron in the outermost shell. So the number of valence electron gradually increases. The number of valence electron gradually increases. This leads, this leads to an increase in effective nuclear charge. Hence, atomic size decreases across a period. Is the explanation clear to everyone? Yes or no?
Yes, sir.
Yes, sir.
Yes, sir.
Well, let's see. Now, let me see whether you can answer this question or not. Whether you can think and answer this question or not. It's a very important short MCQ type of question from this topic, from this chapter. That is arrange in increasing order. In increasing order, order atomic size. Atomic size. The elements given in the question are their ions, they are not atoms. So the ions that are given Cl minus, Ca2 plus, S2 minus, K plus, argon. Can you solve this question?
Yes, sir.
Yes, you can do. So good. Tell me what you can answer. Increasing order. Vale? That's more or less. You solved it. So what's your answer?
Sir, 1 minute, sir. Sir, Cl,
Then
argon,
then
potassium,
then
calcium.
and then you have written sulfide.
Sulfur will be first.
Sulfur will be first. So which one is the smallest one according to you? According to you?
The smallest one is sulfur.
Smallest one is sulfur. But which one is the largest one according to you?
Sir,
Calcium.
calcium.
Calcium. So, what is the logic? What is the logic that you use over here? What is the reasoning that you use? What is the logic that you have used? Okay. It's basically you have told just the opposite. Over here, calcium 2 plus will be the smallest in size, whereas S2 minus is going to be the largest in size. So now let's just arrange them in this way. Suppose Ca2 plus then will come K plus. Then we are going to get argon. Then we'll be getting Cl minus. And then we'll get S2. This will be the answer. But how? Now tell me, how many electrons calcium has normally? Calcium normally has 20 electrons. Normally, calcium has 20 electrons. Now over here, calcium is 2 plus. So that means 2 electron has been lost. So there are 18 electrons over here. And how many protons are there? Obviously, the number of electron is equal to the number of protons. Normally, there will be 20 protons only. Proton so cannot be lost. Proton is present inside the nucleus. Proton cannot be given up. So there are 18 electrons and 20 protons. Now think about potassium. How many electrons does normal potassium has? Normal neutral potassium has 19 electrons. That means 19 protons also. This has 19 protons. Okay. But it is K plus. That means it has lost one electron. It has given out one electron. So that means now there are 18 electrons and 19 protons. How many electrons does argon have? Argon has 18 electrons only. That means it will have 18 protons also. Then how many electrons does normal neutral chlorine has? It has 17 electrons. That means it will have 17 protons. But it is Cl minus. That means one electron is extra. So again 18 electrons. How many electrons does sulfur has? Neutral sulfur. It has 16 electrons. So that's why it has 16 protons. But the sulfur has excess electron. That is why S2 minus, 2 excess electron, S2 minus. So that's it, 18 electrons. So all these species has the same number of electrons. All these 5 species that I have written has the same number of electrons. What do we call such species? We have done in the first class of atomic structure. What is such species? Known as? These are known as isoelectric species. Species having the same number of electrons are called the isoelectric species. Now let's see the answer. What will happen over here? Think this like don't go into the chemical technicality. Think it like a simple tug of war competition happening. You know tug of war, right? You understand what tug of war is? Do you know what tug of war is?
Sir, no.
Okay. Tug of war মানে হচ্ছে যে see there's a rope kind of thing. Then there are participants on both the side pulling the ropes.
Yes, sir, no.
Have you seen this kind of game? It
Yes,
happens
sir.
in sports also, right? So basically, the one who can pull the rope to the side is the winner of the game. So that's the tug of war. Okay, so there are persons on both the sides who are pulling the ropes like this. And again, there are opponents also pulling the ropes on the opposite side. So this, the red persons are pulling the rope to their side, and the green person are trying to pull the rope to this. So now the side which has a greater amount of strength will win the game. So this game is called tug of war game. Anyways, so think this also to be kind of like a tug of war game. So over here for calcium 2 plus, how many protons are there? There are 20 protons. So on this side you have 20 protons. And on the opponent side, how many do you have? 18 electrons. So obviously 20 proton will be more powerful than these 18 electrons. So that means the proton will pull the nucleus towards itself. That means protons are present in the nucleus. So that means 20 protons are pulling 18 electrons. So that's why the atomic size will decrease. Because this side has a greater number of people, that's why a greater number of strength. So they are pulling the 18 electrons close to the nucleus. So that is why the size of Ca2 plus will decrease. Now let's see for potassium. For potassium, you are getting there are 19 protons. There are 19 protons, and on the opponent side you have 18 electrons. So here also the strength of proton is more because there are 19 protons. So the 19 protons will win this tug of war game. They will pull the 18 electron closer to itself. That is what the size of K plus will also decrease. But obviously Ca2 plus will be smaller than K plus because over there are 20 protons pulling 18 electrons. It's a much stronger team, 20 protons. Whereas for K plus, there are 19 protons pulling 18 electrons. The pull by the proton, that is the nucleus, will be comparatively lesser for K plus. So that is why Ca2 plus is smaller than K plus. Now what about argon? For argon, it is kind of a tie game because 18 on both the sides, 18 protons and 18 electrons. So that's why argon will be intermediate inside, it will be normal. Nothing small, nothing large, it's normal. Now see for Cl minus. For Cl minus, you are getting to see that there are 17 electrons. There are 17 electrons in Cl minus. Sorry, there are 17 protons and 18 electrons in this Cl minus. So now the electrons side has become more stronger. So they will pull towards themselves, they will pull the rope towards themselves. So that is why size will increase. For sulfide, the electrons are becoming even more stronger because there are 16 protons against 18 electrons. So over here, that is why the size will get even more larger. So hence the order, the increasing order of atomic size is going to be calcium 2 plus less than potassium plus, less than argon, less than Cl minus, less than H2 minus. So from here you can conclude that this is a very important conclusion that a cation is always smaller than its corresponding neutral atom. And an anion is always larger than its corresponding neutral atom. So you imagine it like a game kind of situation. If the number of protons are more, that means atomic size will decrease. If the number of electrons are more, the atomic size will increase. Okay. Is the question and its answer clear to everyone?
Yes, sir.
Yes, sir.
So if the number of protons are more than the number of electrons, then atomic size will decrease. Greater the number of proton, smaller will be the atomic size. Whereas if the number of electrons are more than the number of proton, then the atomic size will increase. Greater the number of electrons, larger will be the atomic size. Okay, so this was about the ions arrangement in the EP order. So yeah, so we'll be stopping here today, and in the next class, that is on Friday. On Friday, we'll be discussing about lanthanide contraction and other things about this atomic size only. Okay, of the 4 periodic properties, the atomic size is a bit larger. The other ones are not that large as that. Atomic size will take time, and the others will like take one class each. Other periodic properties will be done. Okay, that's it for today. So is everything about today's class clear to everyone?
Yes, sir.
Yes, sir.
Okay, so kindly revise.